Grounding requirements for jacuzzis and single-family dwellings involve several key aspects to ensure electrical safety. Firstly, electrical grounding is essential. Jacuzzi motors must be grounded to the electrical grounding system of the dwelling. This is typically achieved by connecting the ground wire of the jacuzzi to a grounding electrode system, often referred to as GES. Acceptable components of a grounding electrode system include a water pipe grounding electrode, such as a cold water pipe, a ground rod electrode, and a foundation electrode. Secondly, equipment grounding is also critical. The jacuzzi motor must be bonded to the jacuzzi frame using a bonding jumper. Furthermore, the jacuzzi frame must be grounded to the grounding electrode system, that is GES, using a separate grounding electrode conductor. Thirdly, ground fault circuit interrupter, GFCI, protection is paramount. All jacuzzi installations must be protected by a ground fault circuit interrupter. This device diligently monitors the current flow and trips instantaneously if there is an imbalance, immediately indicating a ground fault. Focusing on the specific requirements for grounding to a cold water pipe, according to the National Electrical Code, NEC. Grounding to a cold water pipe is indeed an acceptable method of grounding for jacuzzi motors. However, there are stipulations. The cold water pipe must be made of metal and must maintain direct contact with the earth. The grounding conductor must be securely and properly connected to a cold water pipe utilizing a clamp or another method that is approved and compliant with NEC standards. Additional considerations are of great importance. It is highly recommended to engage a licensed electrician to perform the grounding installation. This is essential to ensure full compliance with all applicable National Electrical Code requirements, alongside any and all local codes and regulations. If the cold water pipe is not readily accessible or if it is constructed of plastic, alternative grounding methods must be implemented, such as the installation of a dedicated ground rod electrode. Finally, regular inspection and maintenance of the entire grounding system are indispensable for maintaining optimal safety and performance. The National Electrical Code, NEC, provides comprehensive guidelines for grounding and bonding to minimize electrical hazards. Grounding creates a low impedance path for fault current to return to the source, tripping the overcurrent protective device, such as a circuit breaker or fuse, and de-energizing the circuit. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of shock. Article 250 of the NEC covers grounding and bonding requirements. Section 250.50 addresses grounding electrode systems, specifying that all available electrodes must be bonded together to form a single grounding electrode system. Acceptable grounding electrodes include metal water pipes, ground rods, ground rings, and concrete encased electrodes, often referred to as U for grounds. Section 250.52 details the requirements for specific grounding electrodes. For example, a metal water pipe electrode must be in direct contact with the earth for at least 10 feet. A ground rod electrode must be at least 8 feet long and driven into the ground. Section 680 of the NEC covers swimming pools, spas, hot tubs, and similar installations, providing additional requirements for grounding and bonding. Section 680.26 specifically addresses bonding of metal parts. All metal parts within 5 feet of the inside walls of a pool or spa must be bonded together using a solid copper conductor not smaller than 8 American wire gauge. This includes metal conduit, metal piping, and metal fences. Section 680.42 outlines the requirements for spas and hot tubs. All metal parts of a spa or hot tub, including the equipment grounding conductor for the pump motor, must be bonded to the equipment grounding bus. The bonding conductor must be solid copper and not smaller than 8 American wire gauge. Ground fault circuit interrupters, GFCIs, are required for all circuits supplying power to spas and hot tubs. A GFCI detects ground faults, which occur when current flows through an unintended path, such as a person's body. When a ground fault is detected, the GFCI trips the circuit, cutting off power and preventing electric shock. GFCIs are typically rated to trip at 5 mA. Proper grounding and bonding are essential for electrical safety in and around jacuzzis. Improper grounding can lead to electric shock, fire, and equipment damage. It is crucial to follow all applicable codes and standards when installing and maintaining a jacuzzi. Regular inspection and testing of the grounding system can help identify potential problems before they become hazards. A qualified electrician should perform all electrical work related to jacuzzis to ensure compliance with safety regulations. Here are some additional details regarding the different components of a grounding system. The grounding electrode conductor (GEC) connects the equipment grounding bus to the grounding electrode system. The size of the GEC is determined by the size of the service entrance conductors, as specified in NEC Table 250.66. The equipment grounding conductor (EG) connects the non-current carrying metal parts of electrical equipment to the equipment grounding bus. The size of the EGC is determined by the rating of the overcurrent protective device protecting the circuit, as specified in NEC Table 250.122. Bonding jumpers are used to connect different metal parts together to ensure electrical continuity. Bonding jumpers must be sized according to NEC Table 250.102. Ground rods are typically made of copper or copper-clad steel. They must be at least 8 feet long and driven into the ground to a depth of at least 8 feet. The resistance to ground of a ground rod should not exceed 25 ohms. If the resistance is greater than 25 ohms, a second ground rod must be installed at least 6 feet away from the first ground rod. Metal water pipes used as grounding electrodes must be in direct contact with the earth for at least 10 feet. The water pipe must be electrically continuous and free of any insulating joints or unions. Concrete encased electrodes, also known as UFA grounds, consist of at least 20 feet of bare copper conductor encased in concrete. The concrete must be in direct contact with the earth. UFA grounds are typically installed in the footings or foundation of a building. Regular inspection and maintenance of the grounding system are essential for safety. The grounding connections should be checked periodically to ensure that they are tight and free of corrosion. The resistance to ground of the grounding electrode system should be tested regularly to ensure that it meets the requirements of the NEC. If any problems are found, they should be corrected immediately by a qualified electrician. In addition to the NEC requirements, local codes and regulations may also apply. It is important to check with the local authorities to determine the specific requirements for grounding and bonding in your area. Failure to comply with these requirements can result in fines, penalties, and even legal action. Proper grounding and bonding are essential for electrical safety. By following the NEC requirements and local codes, you can help protect yourself, your family, and your property from electrical hazards. Remember, electricity can be dangerous. Always exercise caution when working with electrical equipment. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Here are some specific examples of how grounding and bonding are applied in a jacuzzi installation. The metal frame of the jacuzzi must be bonded to the equipment grounding bus using a solid copper conductor not smaller than 8 American wire gauge. The pump motor must be grounded to the equipment grounding bus using an equipment grounding conductor sized according to NEC Table 250.122. All metal parts within 5 feet of the inside walls of the jacuzzi, such as metal conduit, metal piping, and metal fences, must be bonded together using a solid copper conductor not smaller than 8 American wire gauge. A ground fault circuit interrupter, GFCI, must be installed to protect all circuits supplying power to the jacuzzi. The GFCI must be rated to trip at 5 mA. The grounding electrode system must be installed in accordance with NEC Section 250.50. The grounding electrode conductor must be sized according to NEC Table 250.66. The grounding connections must be tight and free of corrosion. The resistance to ground of the grounding electrode system must be tested regularly to ensure that it meets the requirements of the NEC. By following these guidelines, you can ensure that your jacuzzi is properly grounded and bonded, providing a safe and enjoyable experience. Understanding the NEC tables referenced is crucial for proper implementation. NEC Table 250.66 dictates the size of the grounding electrode conductor for alternating current systems. The size of the grounding electrode conductor is based on the size of the service entrance conductors or the equivalent area for parallel conductors. For example, if the service entrance conductors are 2/0 American wire gauge copper, the grounding electrode conductor must be at least 6 American wire gauge copper. NEC Table 250.122 specifies the minimum size of equipment grounding conductors for grounding raceway and equipment. The size of the equipment grounding conductor is based on the rating of the overcurrent protective device in the circuit. For example, if the overcurrent protective device is rated at 20 amps, the equipment grounding conductor must be at least 12 American wire gauge copper. NEC Table 250.102 provides guidance on sizing bonding jumpers and connection straps. The size of the bonding jumper depends on the size of the circuit conductors. For example, if the circuit conductors are 1/0 American wire gauge copper, the bonding jumper must be at least 6 American wire gauge copper. It is important to consult these tables directly in the NEC to determine the correct sizes for grounding and bonding conductors in specific situations. Using the wrong size conductor can compromise the effectiveness of the grounding system and increase the risk of electrical shock. Furthermore, always remember to use approved connectors and methods for making grounding and bonding connections. Improper connections can create high resistance points that impede the flow of fault current. Grounding clamps used on water pipes must be specifically listed for grounding purposes and must be installed according to the manufacturer's instructions. Similarly, when connecting to ground rods, use listed connectors that are suitable for direct burial. In addition to the grounding requirements, there are also specific wiring methods that must be followed for jacuzzi installations. Wiring must be installed in conduit or be identified for direct burial. The wiring must be protected from physical damage. All electrical connections must be made in approved enclosures. The enclosures must be weatherproof and suitable for wet locations. The location of the disconnect switch is also important. The disconnect switch must be readily accessible and within sight of the jacuzzi. This allows for quick and easy shutoff of power in case of an emergency. The disconnect switch must be clearly labeled to indicate its purpose. Regular maintenance of the electrical system is also crucial. Check the wiring and connections regularly for any signs of damage or corrosion. Test the ground fault circuit interrupter (GFCI) periodically to ensure that it is working properly. Have a qualified electrician inspect the electrical system at least once a year. By following these guidelines, you can help ensure that your jacuzzi is safe and compliant with all applicable codes and standards. Remember, electrical safety is paramount. Always take precautions to protect yourself and your family from electrical hazards. When in doubt, consult with a qualified electrician. Consider the environment when selecting materials. For example, if the jacuzzi is located near saltwater, use corrosion-resistant materials. Stainless steel and copper are good choices for saltwater environments. Protect wiring from sunlight and extreme temperatures. Sunlight can degrade insulation and cause wiring to become brittle. Extreme temperatures can also damage wiring and connections. Use weatherproof enclosures and fittings to protect electrical components from the elements. Be aware of potential hazards such as tree roots and rodents. Tree roots can damage underground wiring. Rodents can chew on wiring and cause short circuits. Protect wiring by burying it deep enough to avoid tree roots. Use rodent-resistant conduit to protect wiring from rodents. Follow all manufacturer's instructions when installing electrical equipment. The manufacturer's instructions provide important information about the proper installation and operation of the equipment. Failure to follow the manufacturer's instructions can void the warranty and create safety hazards. Keep electrical panels and disconnect switches clear of obstructions. This allows for quick and easy access to the electrical system in case of an emergency. Never overload electrical circuits. Overloading a circuit can cause the wiring to overheat and create a fire hazard. Use the correct size circuit breaker for each circuit. If you are not sure what size circuit breaker to use, consult with a qualified electrician. Be careful when using extension cords. Extension cords should only be used for temporary purposes. Do not use extension cords as a substitute for permanent wiring. Use heavy-duty extension cords that are rated for outdoor use. Do not run extension cords under rugs or carpets. Do not overload extension cords. Inspect extension cords regularly for any signs of damage. Replace damaged extension cords immediately. Keep electrical equipment away from water. Water can conduct electricity and create a shock hazard. Do not use electrical appliances near water. Do not touch electrical equipment with wet hands. If electrical equipment gets wet, unplug it immediately. Call a qualified electrician to inspect the equipment before using it again. Teach children about electrical safety. Explain the dangers of electricity to children. Teach them not to touch electrical equipment with wet hands. Teach them not to play with electrical outlets or cords. Teach them to tell an adult if they see something that looks dangerous. By following these simple tips, you can help protect yourself and your family from electrical hazards. Electricity is a powerful force. Treat it with respect and always take precautions to stay safe. It's worth reiterating the importance of ground fault circuit interrupters. GFCIs are a critical safety device that can prevent serious injury or death. They work by monitoring the current flowing through a circuit. If the current flowing into the circuit is different from the current flowing out, the GFCI will trip and shut off the power. This happens very quickly, typically within a fraction of a second. GFCIs are designed to protect people from electric shock. They are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. They are also required for jacuzzi installations. There are two main types of GFCIs: receptacle-type GFCIs and circuit breaker-type GFCIs. Receptacle-type GFCIs are installed in place of standard electrical outlets. They provide GFCI protection for anything plugged into the outlet. Circuit breaker type GFCIs are installed in the electrical panel. They provide GFCI protection for the entire circuit. To test a GFCI, press the test button on the device. This should cause the GFCI to trip and shut off the power. To reset the GFCI, press the reset button. If the GFCI does not trip when you press the test button, or if it trips frequently for no apparent reason, it should be replaced. It is important to test GFCIs regularly to ensure that they are working properly. A good practice is to test them monthly. Also, remember that GFCIs do not protect against all electrical hazards. They do not protect against overloads or short circuits. They only protect against ground faults. For overload and short circuit protection, you need to have the proper size circuit breakers installed. In summary, proper grounding and bonding are essential for the safe operation of a jacuzzi. It is crucial to follow all applicable codes and standards when installing and maintaining a jacuzzi. Regular inspection and testing of the grounding system can help identify potential problems before they become hazards. A qualified electrician should perform all electrical work related to jacuzzis to ensure compliance with safety regulations. Grounding minimizes the risk of electrical shock by providing a path for fault current to flow back to the source, tripping the overcurrent protective device. Bonding ensures that all metal parts are at the same electrical potential, reducing the risk of shock. GFCIs provide an additional layer of protection by detecting ground faults and shutting off the power quickly. By taking these precautions, you can help ensure that your jacuzzi is safe and enjoyable for years to come.